Okay, so hi everyone. As Henrik just said, my name is Florian and I come from the University of Glasgow. And today I am going to present a framework to co-optimize task and social dialogue policies using reinforcement learning. This work is grounded in the conversational goals theory from Stacy and Copeland. According to this theory, people tend to pursue multiple goals when they're in a conversation. These goals can be either propositional, so make the task move forward, or interpersonal, for instance, build a relationship with the other person. If we look at human-computer interactions, we can find a pretty similar dichotomy. For instance, if we look at personal assistants such as Alexa or Google Home, these systems are designed to help users to achieve a specific task. So they basically focus on the propositional goal of the interaction. On the other hand, you can find chatbots such as Elisa or more recently Microsoft's Charis, and these chatbots are not really helping users to achieve a specific task. Instead, they focus on the interpersonal goal of the interaction. And finally, we have what we call socially aware conversational agents. And these agents are able to fulfill both propositional and interpersonal goals at the same time. And that's the type of agents I'm going to talk about during this talk. One of the main challenges for these socially aware conversational agents is to select the optimal dialogue policy that will help them to fulfill both task and social goals at the same time. It can be pretty easy to handcraft a simple dialogue tree mapping dialogue states to actions. That becomes quickly overwhelming when the dialogue is really complex and deep. So one solution to overcome this problem is to rely on reinforcement learning and directly ask users to give feedbacks or rewards to the agent depending on the action it takes given a specific dialogue state. So reinforcement learning has been proven to be pretty effective and it's super cool, but there is still one issue, which is that it requires a lot of data. And usually we don't have a lot of data available to train agents. So one solution to overcome this problem is to develop user simulators. User simulators can be seen as artifacts that can emulate or approximate the behaviors of real human users. And with such artifacts, we could potentially generate an infinity of interactions that we could then use to train our agent. If we look at the literature, there are already a lot of works that try to train an agent and optimize our policies using reinforcement learning and user simulators. Most of these works focus on the propositional goal of the interaction, and they build systems that try to achieve a task as fast as possible. But there are also other works that focus on the interpersonal goal of the interaction. And these systems try to either optimize their social behavior or try to optimize their task behavior or both. But one issue with all these systems is that they consider there is only one single policy that can be optimized regardless of the user's conversational goals. And that leads us to the following research questions that we're going to investigate. The first research question, we want to investigate how users' conversational goals could potentially impact the agent's dialogue policy. And for our second research question, we want to understand how we could potentially optimize an agent's dialogue policy depending on its user's conversational goals. So to answer these two research questions, we designed the following framework. So this framework consists in 6 steps that I'm going to briefly introduce before we go into details. The goal of the first step is to rely on theory and data to create a rule-based agent and a user simulator that could communicate at the dialogue act level. Here, the goal is to have a baseline that we want to improve basically in the end. In the second step, we want to map each of these dialogue acts into sentences using natural language, and that will be then authoring step. And in the end, we could potentially generate a bunch of synthetic dialogues that humans could actually read and understand. In the third step, we want to annotate these dialogues using a single score of rapport, representing how well the interaction went. We could use this data set of annotated interactions to answer to our first research question. and also use these data sets to design our reward model that we could rely on in the fifth step of our framework to train our agent using reinforcement learning. That way, we could also answer to our second research question. There's also a sixth step in this framework that we are not going to cover today, but the goal of this sixth step is to evaluate our agent and to use lifelong learning to fine-tune the data policies. Now that I gave you some overview of the framework, let's go into details and talk about each of these steps. The goal of the first step is to build a rule-based agent and a simulated user. The propositional goal of the rule-based agent is to recommend movies to its users. And for that, we relied on the traditional interview delivery structure in which the system first greets the user, introduces itself, then gathers users' preferences before it recommends movies, and then once the user is satisfied, the system can say bye-bye. At each turn, the agent can also acknowledge what the user previously said. The combination of dialogue act and acknowledgement is what we call here a task action. For the interpersonal goal of our agent, we relied on rapport. So basically, we want our system to build rapport with its users. And for that, we used the computational model of rapport from Zhao that determines a list of conversational strategies that people use to build rapport during an interaction. And more specifically, we relied on 4 different conversational strategies. The system can self-disclose personal information, it can praise the user, it can hedge or use indirectness, and it can also violate social norm or tease the user more gently. And these conversational strategies are what we call here social actions. So at each turn, we can have a combination of task and social actions. For instance, here, the agent can acknowledge what the user just said with a self-disclosure and say, oh, you said you love Tom Cruise, he's also my favorite actor, and then move on by recommending a movie without conversational strategy. So, hey, what about Top Gun? So here, this is what we want to do. We want to optimize the dialogue so that we can pick the best combination of task action and social action given a specific dialogue state. Now that we have an agent, we also need to talk about the user simulator. So the user simulator also generates both task and social actions and is defined by 3 different dimensions. The first dimension represents the user's preferences in terms of favorite actor, director, and genre. Then we also represent the user's conversational goals. So here we rely on our previous work to determine 2 different types of users. We have I-type users that focus on both propositional and interpersonal goals. These users basically use a variety of conversational strategy during their interaction. Then we also have P-type users, and these P-type users only care about the propositional goal. So they are straight to the point, and they never use any kind of conversational strategy during the interaction. And finally, the last dimension represents how likely a user is to accept a recommendation. This depends on the user type and on the level of rapport that was being built during the interaction. And that also comes from our previous work. So now that we have a list of tasks and social actions for both the agent and the user, we can move to the authoring phase, the second step, which is actually pretty straightforward. So here, during the second phase, we hired 3 different writers, and to be sure that the sentences they will write would convey the correct meaning, we first trained them during an annotation task. The goal of this annotation task was to make sure that the 3 writers would actually agree on what these conversational strategies were. And once they agreed, we asked each of them to write 1 sentence corresponding to task plus social action combinations. And for the acknowledgements, we also gave them the previous sentence in the introduction as a context. So now that we have authored all the sentences, we can generate a bunch of synthetic dialogues that humans could read. And then in the third step, we want to annotate these dialogues with a single rapport score. But we also want at the same time to answer to our first research question. We want to understand how users' conversational goals could impact conversational agent dialog policy. So rather than randomly generating interactions and analyzing them, we designed the following experiment. So we generated interactions depending on two different variables. The first variable represents the type of users. So we have P-type users and I-type users. And the second variable represents the type of agents. So here we have task-only agents that will never use any kind of acknowledgement or conversational strategy during the interaction. We also have partly social agents that will use acknowledgement, but they will never use conversational strategies. And we had fully social agents that could both use acknowledgements and conversational strategy during the interactions. So in the end, we have 6 different conditions representing different combinations of user type and agent type. We generated 15 interactions for each condition, which led us to 90 interactions in total. And we hired again 3 annotators to annotate these different interactions with a single score report. And here are the results. Our factorial ANOVA analysis revealed a significant interaction between the user type and the agent type. And when we looked at the post-hoc analysis results, we found out that rapport was actually significantly higher when both the agent and the user actively tried to fulfill their interpersonal goals. So rapport was really high when I-type users were interacting with a fully social agent, which is kind of expected. But what is interesting is that rapport was significantly lower when either the agent or the user used conversational strategies. For instance, here, if P-type users interacted with fully social agents, the rapport was actually pretty low. And we have the same with I-type users interacting with the task-only agent. Here, rapport was pretty low. That's actually pretty interesting here. But we wanted to know more, and we wanted to understand what kind of conversational strategies were actually the most effective in order to build rapport during an interaction. And for that, we built a rapport estimator, and we tried different regression model, and we found out that the ridge regression one was the best. And when we looked at the weights associated with each of the conversational strategies, we realized that when the system was acknowledging what the user just said, it was better to use a self-disclosure and a praise along this acknowledgement. But when the system was initiating dialogue acts, it was better to have a self-disclosure, a praise, or some kind of violation of social norm. So here, not using any kind of social strategy was not really helping to build rapport, which is again expected. So now that we know a little bit more about how rapport is being built and how the conversational strategies and users' goals interfere with reports, we can design our reward model. And here we determine 2 different types of rewards. For the task reward, we gave the system a small positive reward whenever the user accepted a recommendation, and we penalized the dialogue length and any kind of repetitions in the dialogue. For the social reward, we designed 2 different types of models. For I-types, basically, the higher the report was during the interaction, the better the reward was in the end. For P-type users, we basically checked the ratio of non-conversational strategies that was used during the interaction. And the higher the ratio, the better the reward was at the end when systems were interacting with P-type users. So now we can use this reward model and the dataset that we have to train our agent, and that's the 5th and last step. So rather than blindly trying to explore the large action space that we have, we started by bootstrapping the learning of the agent using our annotated dataset. That basically gives some kind of a baseline for the agent to start with, rather than starting from scratch and learn from using. We trained 2 different kind of agents. The first agent was called the unimodal agent and had 1 single policy. This agent considered that all users were I-type. So we tried to build rapport with any kind of users it interacted with. And then we also trained a bimodal agent that had two different policies depending on users' goals. So we tried to build rapport with high-type users and try to maximize this non-conversational strategy ratio with P-type users. And here are the results of the training. So we used Q-learning and we trained the agent over 20,000 epochs. And if we look at the task rewards, we can see that basically all the systems perform the same. That's kind of what we expect. And we can see that the rule-based agent is having similar performance than the other reinforcement learning agents. What is more interesting is to look at the social rewards. Here we can see that the rule-based agent is performing pretty badly. And that's because the rule-based agent is randomly selecting a conversational strategy at each turn, which does not really help to build rapport. The unimodal reinforcement learning agent is performing slightly better, but we can see that it struggles to keep and maintain some kind of positive rewards during the whole epoch training phase. But the bimodal agent actually managed to keep a positive reward and actually learn some kind of dialogue policy, and it actually learns to adapt its dialogue policy towards different goals. And if we look at the total rewards, we can see that the bimodal agent is actually outperforming the two other ones. So quickly, because I don't have many time left, to conclude, we presented in this work a 6-steps process that we use to optimize task and social dialogue policies for conversational agents. From the first research question, we learned that rapport depends on both users' conversational goals and the conversational agent's dialogue policy. And from the second research question, we realized that an agent that can distinguish between user types could actually accumulate more reward. And just quickly finish about the future work, we would like to add some kind of noise module to the user simulator to generate some kind of misunderstanding. We would also need to improve the rapport estimator using more data and maybe a fancier model, some kind of recurrent neural network or something like that. We also definitely need to use hierarchical reinforcement learning rather than flat reinforcement learning that we use, because it gives much better results. And finally, the final step would be to evaluate the agent with real users, of course. So I guess I'm done. Thank you very much for your attention.